All right, let's start the next section. In this section, we are going to be learning some more advanced integral techniques. And this technique is going to be a technique that we is going to be using a technique called U substitution. And what U substitution basically is the reverse of the chain rule. And it only works in specific circumstances, and so the problems in this section are actually going to be rigged in such a way that the U substitution technique will work. So let me just show you the idea with an example. You notice we have this complicated looking integral, and you could, I suppose, just multiply it all out and solve it that way, but there's a quicker way. So the idea is you want to pick what your u is going to equal. And what you're looking for is you're looking for something that if you let u equal it, the derivative of u is something else in your integral. So in looking at this, I have x cubed plus 3, all of that being squared, and then this 3x squared over here. And so you want to cram as much as you can into u, and so that when you take the du, when you take the derivative of it, you get something else in your integral. And so in this example, I see I have x cubed plus 3 here, and if I take the derivative of that, I'll get 3x squared, which is really nice. So let's see how you would do this. You would say u is equal to x cubed plus 3. And honestly, that's the hardest part of this problem, is picking out the u. If you're doing this and your u is just not working out, then that means that you probably need to pick a different u. So we have u is equal to x cubed plus 3, which means that du dx is equal to 3x squared. Okay? Now, what makes this work is that not only do we substitute in our u, but we also need to substitute our dx. We basically have to get rid of all of the x's in the integral and only get u's. So watch what I'm going to do. I'm going to move this dx over, so I get du is equal to 3x squared dx. All right? Then what I'm going to do is I'm going to divide by 3x squared. And so notice I get dx is equal to du over 3x squared. Okay? And so now we're ready to go. I'm ready to substitute in my dx, and I'm ready to substitute in my u. And it'll look like this. The integral of, we can get rid of x cubed plus 3 and make that u squared. Then I have the 3x squared times, and now I substitute in my du over 3x squared. And notice that when we do that, the 3x squareds cancel, and so we get the integral of u squared du. You've done that correctly if you've managed to get rid of all of your x's. If you got rid of all of the x's, you can proceed. If you have any x's left over, then that means you did not do the u substitution quite correctly. Now, these two steps are actually optional. I like to do them because for people doing this for the first time, it's easier to just plug in and cancel. But do notice that we had du equals 3 squared dx. Do you see that? Du equals 3 squared dx. Notice I have 3 squared dx right there. And so that 3 squared dx just becomes du. So if you can visually see 3x squared dx becoming du, go ahead and just do it. But if you're not comfortable with that, go ahead and just solve for dx. Then substitute in for just the dx. Then the other stuff should just cancel. So you can use either method. You'll notice that this integral is pretty simple. That's just going to be u cubed over 3 plus c. And now, to finish off, all we need to do is just plug in back our substitution. So the answer is x cubed plus 3 to the third power divided by 3 plus c. And don't forget that you can test your answer by taking the derivative of it and seeing if it works out. Now, the reason this problem was relatively straightforward is all thanks to that 3x squared. If I mess with this 3x squared in pretty much any way, if I make it x cubed or x to the 5 or e or anything else, this U substitution doesn't work anymore and we have to pick a different method. So a lot of these problems are going to be rigged so that we can, use U substitution. Let's go ahead and stop here, and in the next video we'll do a second example.